Ever pondered the destiny of planets when their star breathes its last? The cosmic dance of life and death is not only limited to the beings on Earth. Even stars, those glowing orbs of gas, are not exempt. They too have a life cycle, and much like us, they do not survive forever. This includes our sun, a seemingly eternal beacon of light and heat that has nurtured life on our planet for billions of years. In about 5 billion years, a significant turn of events will unfold. Our sun will start to exhaust its supply of hydrogen, the crucial ingredient it uses to generate energy. This process, known as nuclear fusion, happens in the sun's core. As the hydrogen supply diminishes, the core begins to contract, thereby increasing the temperature. This, in turn, ignites fusion reactions in the sun's outer envelope, causing the sun to expand. This expansion marks the beginning of what astronomers call the red giant phase. The sun, along with other stars like it, will swell up to a size so massive that it dwarfs its current dimensions. Imagine, if you will, our sun growing to such an extent that it engulfs Mercury, Venus, and probably even Earth. A truly apocalyptic vision, isn't it? As the sun becomes a red giant, it spells doom for any planets in its immediate vicinity. They are likely to be swallowed up, consumed by the very star they once orbited. However, this isn't the end of the story. There are other planets, those farther out, that may have a different fate awaiting them. The red giant phase is a grim fate for neighboring planets. But what about those farther out? Could they survive the death of their star? And could they perhaps even become capable of supporting life? The answers to these questions lie in the understanding of the complex processes that continue to shape the universe around us. As a star swells into a red giant, the Goldilocks zone of habitability shifts outward. This is the dramatic shift in the cosmic neighborhood that could spell doom or hope for planets in the system. Let's consider our very own solar system. The sun, like all stars, is destined to expand into a red giant. In this phase, the sun's outer envelope will ignite fusion reactions, causing it to grow in size. This expansion spells disaster for the inner planets, including Earth. They are likely to be engulfed by the swelling star, their existence relegated to cosmic history. However, for the outer planets and their moons, this could be a new dawn. Worlds that are 5 to 6 times farther from their star than Earth is from the sun will be warmed by the expanding star. The icy moons of Jupiter, such as Europa and Ganymede, could experience a significant rise in temperature. Their icy exteriors will start melting, forming surface oceans. This could potentially create the right conditions for life to emerge. But this scenario is a delicate dance of cosmic forces. These worlds would need to be in the perfect position, too close to the red giant, and their newfound oceans would evaporate. Too far, and they would remain frozen, their potential for life snuffed out. The Goldilocks zone shifts outward, and these worlds would need to inhabit this new zone to potentially harbor life. Yet this period of potentially life-giving warmth isn't a permanent state. The red giant phase is just one stop in the star's journey. The star will continue to evolve, eventually ceasing all fusion reactions. Its outer layers will be expelled, leaving behind only its core, a white dwarf. But that's a tale for another time. The journey of a star is a captivating story of destruction, rebirth, and the potential for life. It's a story that continues to captivate astronomers and space enthusiasts alike. But the journey of the star and its planets isn't over yet. Once a star exhausts all its fusion reactions, it sheds its outer layers, leaving behind its compact core, a white dwarf. These celestial objects are fascinating to say the least. They are born hot and shine brightly like a diamond in the night sky. Yet they are small, about the size of Earth, which means they don't radiate much heat in total. Imagine a world orbiting one of these exotic objects. To host liquid water, essential for life as we know it, the planet would need to be extraordinarily close to the white dwarf. We're talking about a distance of roughly 930,000 miles, about 1% of the distance from Earth to the Sun. Yet there's a hitch. Planets that were once close enough to be engulfed by the star in its red giant phase are long gone, and those that survived are too far to support surface water around the white dwarf. But how can a planet, originally far away, end up in this new Goldilocks zone? Enter tidal migration, the cosmic ballet that could potentially bring a planet close enough to a white dwarf. It's a fascinating dance of celestial bodies, a stellar waltz, if you will. Tidal migration is brought about by dynamical instability between planets in a system. This instability thrusts one planet into a high-eccentricity, comet-like orbit. The planet then swings in a pendulum-like fashion, moving close to the white dwarf and then far out again. But this comet-like orbit is not a permanent state of affairs. Gravity, the great choreographer of our universe, steps in to smooth out the rough edges. It acts to circularize the planet's path, taming the wild swings and keeping the planet in a more stable, close orbit around the white dwarf. In this cozy proximity to the white dwarf, the planet could potentially support life, and it is here, close to the white dwarf, where astronomers could spot their transits, potentially revealing the presence of water and perhaps life.